In order to generate pre-mRNA specific annotations in biochemical probing data tracks, you must first download and unzip Supplemental Data S1. Once downloaded and unzipped, you will see that it is a folder that contains several other folders with different data sets. In the eCLIP folder, you will find the FilterBedFiles.py script, which we will use to generate our tracks. So in order to generate the tracks, the first thing we'll do is create a new folder. I typically call this filtering data, and then we can move our script into that folder. Along with that, we can also open the annotations folder and move in any of these annotations to generate a track for them. So in this case, we'll just use the oregano file, and now we are ready to navigate to our working directory and run the script. So to navigate to your working directory, use the command cd followed by your file path. And once you're in that directory, we can then go ahead and actually run the command that will generate the pre-mRNA specific annotations. So that command is Python, followed by the script name, followed by the genomic coordinates. So in this case, we're looking at MIC. So we will type chr8, and then the genomic coordinates, 127, 735, 434 hyphen 127 742 951, and then we'll give it a outfile name. So since we're looking at the oregano data, we can call it MIC oregano.bed, and then you hit enter. This will run, and you'll see that you have now an outfile in your filtering data folder called MIC oregano.bed, and it does contain data. So once that is finished, we can then remove both the new file and the file used to generate that and bring in any of the other annotations files and repeat the same process, simply changing the outfile name to match what the input is. So the only one that's going to differ is the PolyA site. So if we wanted to do that, well, we can move that into the filtering data folder, and we can run the same exact command, except of course we'll change the out file, so we'll call it PolyA, and then this file does not use the CHR abbreviation, it only needs the chromosome number. So we can do that, press enter, it will run, and once it's finished, we'll see that we now have a new file that contains data. So you can continue this process for all of the annotation files, as well as the eCLIP data or any of the probing data. So you would again take the eCLIP data, move it into the filtering bed file or filtering data folder, running the same command and changing the out file name. For the purposes of this video, I'm not going to actually run that. Since it is a large data file, it will take a bit more time to run than the smaller annotations files, but it's the same process. The same thing could be said for any of the probing data. So for example, for DMS, what I will do is I'll go through and I'll pick out the data sets that match each other. For example, we'll pick out all the DMS in vivo data, and once we have all of those, we can go ahead and move those into the filtering data folder and run our script. So this will be ran in the same way, where we need the chromosome number in this case, and then we just change our outfile name to, in this case, it would be in vivo DMS. And we also want to change the extension to be a bed graph. Now bed graph files will allow you to turn them into heat maps in IGV, so having that extension is important. Again, I'll not show you this, I'll not run it because it does take a substantial amount of time, but I will show you what to do with that data after it's made using a pre-made file. So the pre-made file will look something like this. So the first thing you want to do is go to the top here and put a header on it. So that header will contain track, and then you'll do a space, put type in, equals, and then you'll give it a name. So in this case, we were looking at in vivo DMS data, so I'll just put DMS in vivo. And then you'll also want to put a space after that, type in description, equals, give your quotation marks, and then you can use the same type name for the description, so DMS in vivo. And then once you've finished with that, that's your simple header that will be read by the program. Now you will be changing the type and the description depending on which probing data you're looking at, whether that's DMS in vivo, in vitro, IC shape, in vivo, in vitro, etc. So that will correspond to whatever file you've made. And then the last thing that you want to do is do a find and replace function where you're replacing these NAs with nothing. And you want to do that to prevent any errors in loading the data on IGV. So in this case, I would be able to just find NA, and you also want to delete the tab. So I'll use the \T to find NA in a tab, and we'll replace that with nothing. So we'll hit replace. It will get rid of that, and then you can save that file. And once it's saved, it can be loaded into IGV and visualized as a heat map against all of your other data.